Welcome to Spring LIB.
Hi everyone, so what we have here is a motorcyclist in riding his motorcycle in a hollow sphere. We know that the coefficient of static friction between the wheel and the side of the hollow sphere is 0.4. We know the mass of the motorcyclist and the motorcycle is 250 kilograms, and we know that the radius of curvature is 20 feet. What we're asked to solve for is the minimum velocity required such that when the motorcyclist is at an angle of 90 degrees, that the motorcyclist can still travel along the wall and maintain contact. So what we're asked to do here is use Newton's second laws and the concepts of normal and tangential motion to solve this problem. So what we can do is first draw a free body diagram. So when our motorcyclist is on the side of the wall, we'll just call this the motorcyclist with mass m. There's a normal force coming from the wall. There is a weight force going down. And since this motorcyclist is at an angle of 90 degrees, there is a friction force that is acting in this direction, which we will just call Ff. Now, by summing up our forces in the normal direction, we see that the net force in the normal direction is simply equal to n. So this is equal to mv squared over rho. Next, if we do our forces, or Newton's second law, in the tangential direction, which we'll call Fb, we'll see that this will be equal to our friction force, Ff minus W. Now recall that our friction force is just going to be mu s times n minus W from the weight. And as given to us in our problem statement, mu s is 0.4. So this is equal to 0.4 n minus W, and this is equal to 0. As you can see, we can directly solve for n, and this gives us that n is equal to W over 0.4. We know the mass of the motorcycle and the motorcyclist, so we can solve for n, and we see that n is equal to 6,131.25 newtons. Therefore, we can plug this back into our original equation here and solve for the minimum V required. So we then see that n times rho all over m, the square root, is equal to V, and this gives us a velocity equal to 22.1 meters per second, and that's our final answer.